the backstory? Just can someone turn the clock? Rahul, what we have done in the last session, so that it will be continuation for that fundamentally.
Okay.
Yeah.
Yeah, just a minute. So in last session, we have covered what is MCP and how model context protocol is used in networking, how communication happens, and what is we have taken Claude Desktop as an example and how it works, how it calls the MCP server, and how it calls external APIs, and we also discussed about the layers, different layers in internet. And then HTTP methods, how and information will be transferred from server to client. So we have discussed that, and we have also discussed about communication protocols and what are the formats it uses. So RPC is one of the format we have discussed, and then XML, JSON, and protocols we have discussed about HTTP,
Okay.
TCP, IP.
Yeah.
Yeah.
So that's perfect. So basically, our focus is to make you guys as the ultimate AI engineer in 2026 and beyond. That's the main idea. And if you would like to continue to be same like 2015s and 20s, and basically it's like cutting the branch where you sit. So that's the reason in this overall guide. So we have put multiple things, and out of that, the basic thing, of course, the MCP is also one of the important factor that you need to master. In addition to that, you need to understand the fundamentals of your engineering, and that's where we have started with networking essentials. Okay, now today I'm going to demonstrate, which is something crazy from the MCP, and that in turn will demonstrate why knowing fundamentals of engineering and your networking is very important to become an AI engineer. Okay, so let me share my screen. So we are just continuing where we have left. We have left at the, we have seen the theoretical concepts of networking basics. So TCP, all this TCP IP layer and the physical layers, all types of networkings, and TCP port, TCP sockets we have seen, and we have seen IP internet protocols, and we also seen the WebSockets at the theoretical level, then HTTP, HTTPS protocols, and MTP, FTP, and various other types of protocols and how they are connected. And we have taken a brilliant example from the UPU. So we have just done the analogy of UPU's love story with our networking love story. So now, so before even we see anything, because last time we have spent time theoretically, so before even we understand anything, let's try to go through this demo first. So what you see here is a CLAUDE desktop. Probably everybody knows it. And what you see on the left window is a Blender. Probably few folks in this group might know. So this is fundamentally used for making 3D graphics, visual effects, 3D and videos, and all these 3D objects, 3D scenes, motion graphics, and all can be later taken into the game engines and to make games, to make virtual reality, to make augmented reality. Everything is possible. It's a brilliant thing. Okay. And so now, who's that? Okay. Okay. So now what I have done is, this is my CLAUDE desktop, who is a brilliant, this is my host at this moment. and this is my Blender. It's a separate application altogether running in my machine. This is a separate application altogether running in my machine. Okay. So now the first thing what I've said, can you ping my Blender MCP server? Okay. It has done. Let me check the connection. So it has searched for the tools and it has loaded the first tool, Blender Scene Info, and it has pinged it and it got an information about the Blender. So what it is saying at this moment in the Blender, of course, you guys might not have enough understanding about the graphics and virtual reality. Sejal might have some understanding because she has gone through multiple courses. So if you see from the human perspective, to build a scene, you need to have a fundamental layer, which is a 3D layer, a three-dimensional space, which is x-axis, y-axis, and z-axis, and that's what you see. You got your x, y, and z. And on top of that, the most important thing for you is to have a camera. Okay, because until unless you have a camera, you don't know the weather. So who is camera in real world? Your eyes are your cameras. Okay, so that will decide the view. So you cannot see everything. If you stand, you will only have this 270 degrees of view because you have two eyes. And when you replicate that, it become a virtual reality. That's how the virtual reality came. But this is not the session for the virtual reality anyhow. So now this camera will decide the view. Now, so in reality, now we got the 3D space and you got a camera to get the view. And on top of that, what you need, if you want to see object, if it is dark, you can't see. So the third one, what you need is a lighting. You see that? So you got the lighting. And on top of that, if you want to see something there, there should be some object because the light should fall onto the object and reflect onto the camera. You see that? The light is falling onto the object and reflecting to the camera. And that's where the entire physics of the scene works. So now at this moment, this is a basic scene of Blender. When you load, this is what it will be there. And I've asked my Claude to ping Blender 5.0.1, which is a separate application altogether. I just put them side by side. That doesn't mean they are connected together. It is connected to through some other means. It's going to be crazy. That we will go through it. Okay. Now, so and it has gone through the scene, what it consists of. What it's saying is your Blender MCP server is alive and responding. Perfect, fantastic. And what is the current scene? It consists of a scene, which is, and it consists of a default cube and a light and a camera. And these are the fundamentals of any scene in 3D. Okay, I think I want Rahul to be expert of these things slowly, as he is interested in these things. So soon, I hope he'll show more interest into this virtual and AR. So then, and there are materials which are two materials. Basically, I don't want to get into the details of this 3D graphics and virtual reality at this moment. So when you have, if you want to make an object, for example, if you take Rahul or Ramesh or someone, you have a skeleton, and on top of that skeleton, basically that's a geometry. Your skeleton stuff will give you some rough geometry, and on top of the skeleton, you will put a skin, and on top of the skin, you will add additional stuff. Okay. So now to make any 3D object, you need to have a geometry and you need to have a material, and that will become an object, and we call it as a mesh. Okay. So this, we have two materials in this case, and this is what the present stuff. Now let's do some crazy things. Okay. What I'm going to do is, so I want to build, okay, role, you are visual graphics write a prompt. Okay, let's write a prompt to make Apple phone. Let's take iPhone demo. Okay, so this chain of thought. And let's take, yeah, and let's do co-work to build this. And tool, we're going to use Blender MCP server and their tools. Okay, let's first get the prompt. So once we have the prompt, let's go to the next step. Okay, so now, so what it's doing, so let's build an iPhone model in Blender step by step. So basically, I've given a chain of thought approach so that it would be more efficient. And this idiot has already started working on it. And it has removed the object which it has, and it has removed the camera. It has cleaned up the entire space, because that's what, if when you start any new 3D graphics development, the first thing that you need to do is you need to clean up the space so that you'll create a scene from scratch. So now, so it has come up with the multiple phases. The phase one is to scene setup. So Sejal, I hope you have to focus a lot, because this will be your next important tool that I will hand over, and you have to build a lot of 3D graphics and 3D objects. So you got the scene setup. So clear the existing one, and then lighting and everything. Then phase two, it has to develop a rectangular slab. Then it has to put the glassy face and bezel. And phase four, it needs to have a camera bump. And then finally, it has to add the buttons and all the stuff. And then materials. The most important thing is materials, whether it's a metallic body or a glossy screen, lens screen, all that stuff, that materials will be added on top of the object. Then finally, lighting and camera, and light, render, camera, and on top of that, a bit of animation that is missed, and I will guide it to do that. Okay, so now what it has started, it's already started working on it. You can see that the step one, it's executing the Blender code, and you could do you could see the changes here. So it is started. See, basically you can do in a two ways. One is do step by step. So you first ask to make a scene, then you add 3D rectangular slab, then you add screen, then camera bump. And the other approach is completely hand it over to the Claude desktop, and then just wait for what it does. Okay, so now so far what it has done. So, but the thing is, it's always better to do step by step so that you are well controlled than compared to the one go. And at this moment, we don't have any external uh, materials or the things that we are using here. These are all from the coding. So that is the reason we may not get exact result. But when we use external material, we will have fantastic result and fantastic output. So that can also be done. But at this moment, I just want to show you. Okay, so now the next question, it has done this. So what should we work on next? So add dynamic island. We'll just open it. So let it do. So then we will do one more thing to just explore. Add USB-C port on the bottom edge. Refine. Okay, let's remove this. Let's select render a final hero image and add a screen wallpaper. So you got your camera here. You see that? That's the camera view we got. So at this moment, as I've told you, so this has a geometry, and this also has, in addition to the geometry, it also has the material stuff, right? So now when you want to add these things, so normally there will be open source, there will be some libraries. From there, you can get the real world materials. So if you can directly load them, and we'll get a fantastic output. So now it is all from the coding. So we may not get that exact and very good result because we are not using any third party or external materials. So now if you see what it is doing, our MCP server, we have done some modifications to this MCP server, whatever is available from the web. So we have taken it and we have done some changes. You can see that even your, it will take the screenshot of this particular one and it will get back with the results as well. So that's also has been integrated in this MCP server and that can be done. So I want you guys to make build own MCP servers, and that's what we are expecting. And you see that this is how it's taking a screenshot of what is available there. So this takes a lot of manual efforts. So this will be very useful. And so are you guys able to follow this or? Yeah. Hello.
Hello, sir.
Yeah, Bachi. Upu,
Yes, yes, I am here.
are you able to follow?
Yeah, following.
So what is your understanding so far? What were we trying to do?
Mm. While
Yes, continue.
okay,
No problem.
given understanding how to create and these things,
Mm,
giving the prompts and how can I manage and creating 3D visualizations, or how can I
mm.
give prompts and all. Is it correct or not?
Okay, next. Someone else?
Sir, one side Claude is there, one side Blender is there.
Yeah.
So that cube, we are calling it as mesh,
Yeah.
that object. So we have prompt like in Claude that we have to add
So this
iPhone
time, what we will do is
at the
we'll do
place
it
of
step
that
by
object.
step. Okay.
Hmm.
Let's do it together. Step by step. Step one, set up the scene. And then get the confirmation from me. And we will move to step two. Okay, so now just to build the earth. So what we need to do, Rahul, are you there? Is Rahul there?
Yeah, yeah.
Yeah. So the first thing is basically the scene setup and then texture. So texture is very important. So at this moment we are using the whatever the texture that's available. But when it comes to when we use some open source tools and all, we will able to create a proper exact texture, because Blender is very powerful tool. So this is the full build plan to build a realistic 3D earth. So now what it has done, if you see, the first thing it has built, it has added a 3D sphere. Okay. So now if you want to understand more about the 3D sphere, if I click here, you will get all the information. So now first step is done. Scene one. So this will be useful for learning also. Rahul, are you interested on this? I want you to, because as you are interested in these kind of things, you will have more fun, right?
Exactly. Yeah.
So the scenes. Okay, so just see what we are going to do here now. Now the step one, what we have done. So we have completely cleared off the existing scene, and we have added one camera. That's very important. You're able to see this. This is our camera. You see that? This is our camera. And we have added the lighting. That's a sunlight. We have added the sunlight. So sunlight, basically Rahul might know because he's also a photographer. So there are different types of lights when we do a photography. So one is sunlight. Sunlight would be fundamentally uniform and it falls in a particular direction based on where the sun is, and then so it follows all the physics. And there are different other types of lights as well, and you can use roughly there are 15 to 20 types of lights are available. So now we are using a sunlight, which is directional lamp position to create the realistic day-night terminator. Then we have added a render settings, which is 1920 into 1080, and people knows, whoever knows bit of photography, they knows this value. So now we have created, the first thing that we have done is we have created a sphere, which consists of 64 segments and 32 rings, and with a radius of 1 unit. So fundamentally, whoever knows a bit of mathematics, or if would have studied some mathematics during their primary school, they would able to understand how we make a sphere. Sphere, we make it with segments and rings. So you got the rings laterally and segments transversely. So now we are done with step one. Let's go to step two. So step two is add a realistic earth texture. So here this earth can be shown in a different way with the maps, with maps at night time, with satellite view, with there are different types of showcasing it. So if you want to add a specific texture to this particular sphere, there are a lot of open source, there are a lot of websites where you will able to get those textures. You can just simply download them and you can utilize that. It's very simple. Or so we can do that complete changes in our code so that we can see. You can see that the user perspective, the camera type that we are using is a perspective camera, and so we got sunlight, and you're able to see all those collections here. Okay, I'm just changing the direction just for your benefit, just to see. Now my camera is here. Okay, let me put it back. You see that how we are playing? Okay, so now we are back. So this is the texture that we got, a realistic earth texture. So which is base, we got the ocean land color map, and then we got the polar ice caps, and it has used the surface roughness variance. If you want to zoom in, you can see clearly how it looks. You see that? How fantastic it is. If I keep on zooming in, it's maintaining the peak level of quality, because the Blender is the software which is heavily used by all the visual graphics and 3D graphics designers, and then game engine developers, etc. And this has a brilliant quality. You can literally see that the quality. Okay, so now we are done with the step 2. So we have added the blue oceans and green-brown land masses, and then white polar ice caps and surface bumps and specular variations. So this is what we have done. Now let's get into step 3. So step 3 is fundamentally to add atmosphere around.
So I presume you have written this functions for creating this as an MCP
No,
server, right?
not at all.
You haven't.
Which functions?
So for creating textures, lighting.
Step 4. Let's see what we have written and how it is connected. That's what the fundamental idea is. First, you need to understand the capability. So-called person who does not know Blender can create wonders out of it. That's purely because of artificial intelligence.
Blender and other, yeah, goes hand in hand.
So it's a little complex. It requires a lot of engineering first to understand these things itself. How it is connected, it's little complex stuff. So just being a data scientist, it is not possible. You have to go one step ahead and you have to become an engineer, an AI engineer. And we will explore all those things as we go ahead. But first you need to understand the capability, what it can do. This is with respect to the Blender. And similarly, you can see the MCP servers that I've connected just for this demos. So all these MCP servers are built, and then Unreal MCP and your Blender MCP. So these are all downloaded from GitHub. It was built by someone else, and then so now as these MCP servers were already built, you can customize them for our requirements. So any questions so far? Anyway, Rahul's questions will be addressed as we go ahead. So that's not an issue. Any other questions?
And for every creation of this any structure in Blender, so we need to set the camera also to set the
No,
perspective.
let's keep things simple by the time it, okay. You have a camera. What will you check first? Just think from photographer perspective. You need some subject.
Yeah.
Can you speak out? This is your subject. Okay. That here we call it as an object, a 3D object. Okay. Of course, here everything we consider as a 3D object. Even our camera is also part of this scene. We call it as a 3D object, but we'll just keep that so-called Blender language aside. So you got our subject. So you got your subject, that's your girlfriend that you want to take a pic. So now the next important thing is the scene, scenery. Am I making sense or not? Okay, so you got this scene, a 3D scene. So now you got a 3D scene and you got your subject. So what else is important? The most important thing is light.
Yeah, without light, it will be dark again, right?
Okay. You got light, you got the subject, and you got the scene. But if you don't have camera, what the hell you will do there?
Yeah.
So the camera is the one which is going to take the point of view, a plane of view.
Yeah.
Okay. This lens will decide, okay, this is my scene, and within this, my subject should be here. So if you want to create a 3D scene, of course, there's not a 3D graphics, visual graphics session, but Of course, I want you to be the expert of these things. That's the reason we are just continuing to discuss on this. So you need to have the basic scene setup, and you will have a camera setup. Okay, let me click here. Yeah, you see that this is your camera setup, and you got the light setup from this direction, which is at this moment we are using a simple sunlight, and you got your subject. And on top of that, you can add more other stuff to make the scene brilliant. Okay, now we have only sunlight. Step 5, let's do the lighting refinement. So one side we are doing this, one side we are learning MCP, on other side we are learning the fundamentals of 3D graphics. So here you'll be able to see that you see this is the normal view, and this is your camera view. Basically, if you look at, you will be able to find the camera view. This is your camera view. That's how when you connect this or when you open this object. So this is how the scene will be viewed through this camera. Why it is important? When you are putting this into a virtual reality or game, so the one who is playing the game will not see this entire scene. He will see this 3D object from here through the camera. Example, if you are building a VR application, when you put VR headset, of course you're building this, it's everything is visible to you. But when you put your VR headset, there should be a plane of view, right? These are the things, it should be immediately visible. Then if he moves his head, then everything, like according to that, it should be visible. Yes or no? So this camera decides what should be visible to that guy. So that is the scene is the most important aspect of your this one. So now we have done the lighting refinement that you will able to see here. You see that? And now once this is done,
output also, once this Blender output is rendered, so we will be seeing the camera version, right? Through camera, whatever is visible through camera, same thing will be visible.
no, what you will get is a camera version only, Damachi. Hey, see, Damachi is nice, da. Clouds. See, through cloud.
Yeah.
I'll show you this, how to render this object, and then tool result is too large, maximum size is 1 MB. That's okay. I'll show you how to render these objects and then use it in our VR application. Probably we'll plan that session separately to you and Sejal only. That's what my goal. That's what my target. I want Sejal to be expert of VR and AR. So I will provide all the tools possible so that she does not need to do everything from scratch. Okay, now we are done with step 5. And we are able to create a brilliant object, and even you'll able to create these kind of objects, and you can sell this in marketplace also. It is not only just using for your purpose. Okay, so now let's do some crazy thing. Now let's add step 6, which is starfied background. And then finally we will do the camera and render. So here, just to understand the basics, this is to move, and here you got just to change the view. You see that? This is a different view. Let me put this. And here this is to select, and this is to move this object from here and there. I don't want to do this at this moment. This is to rotate. This is to scale up or scale down. This is to transform the object. And this is to annotate here and right. And this is to add. If you want to do everything manually, these tools can be used. But of course, we are writing a Python code. Sejal,
Yes, sir.
how is it?
Easy, sir. Sir, we
Oh.
can add the location also in that earth?
What is that?
Location, sir.
What is that location?
Sir, any kind of location.
No, I did not get your question at all.
Sir, places.
You want realistic ones?
Hmm.
No, I did not get your question. Locations?
Said location in different countries.
Oh, hmm. How is it done, Machi?
That's
Can you imagine this? Nitin will ask 1 week of time.
within no time we have built this.
And Nitin will ask 1 week of time to us.
Yeah, I think we'll do it manually, slowly 1 week.
Okay, so now let's get to the final step, which is step 7. Step 7 is fundamentally camera and the final render. So after this, we will add a momentum. We'll just add a physics to it. So now, so far we are dealing with mathematics. So now let's add some amount of physics, like how Earth rotates. So we got the camera perspective view.
Can we add motion also here?
Just wait and watch, my dear friend.
Okay.
Thank you. Thank you. Thank you. Pupu,
Yes,
how's it going?
super.
Wow.
It was nice.
Yeah. Pleasure to listen to you. Yeah. And Amlapuram, is he there?
Yes, sir. Yes, sir. It is
Understand.
nice.
So this is actually used the Milky Way kind of design, Milky Way nebula design, because it's part of our universe. So Milky Way is our galaxy, which is part of the observable universe. And I don't want to get into that crazy space science. So if you just want to see, I'll show you exactly what's happening. But first, let's see the output, and then at the end. So the best thing to do this kind of things is, if you have a good PC, run LLM locally and connect that MCP, and then run 24 hours and keep creating these kind of objects and sell them in marketplace, or create some brilliant VR applications. Like, it will be very useful. Eskid is back.
Yeah, I am back.
So far, it's fun.
So far, I see money.
But the actual fun starts.
I think with this we can make many components reusable, right?
No, that's what the fundamental idea. Now, why I'm showing is, so we have planned to build some VR applications. So VR, even game engines I want to build from our under the ndimensions.ai, and this all can be sold in marketplace. Okay, so here it has created a view, how it looks and all. It's called hero section of the Blender. So that's a different thing altogether. I know that's not that important at this moment. So it's a viewport. This is called hero section of Blender. At this moment, XR is niche. So I want to touch that now. And parallelly, we'll continue with our agentic ecosystem and all that. We will not be leaving. So we have to use those to do these things better. So far, any queries or any doubts? Yeah. Yes, Sejal, I think you have some queries.
Sir, me?
Yeah.
Sir, if I want to move that earth round,
And yeah,
sir, can we do that?
of course you can do it. You have to apply some physics to it. So it will do exactly how Earth rotates.
Sir, that babylon.js we have to use or something else?
No, we can do it directly here. We don't have to use anything. So here itself we can do it. We'll do that as a closing of this demo. We will do that as well. So then we will get into the actual topic. So now to understand this, how this happening is what the most important thing. Not executing this. Any queries? Well, before we get into it, any queries, anyone? Yeah. Who's that? Yeah, Bhargav.
Now here we are trying to use a Claude AI to do the graphic kind of design.
Yeah, that's what we are trying to do there. So we are using LLM to create 3D models, including scenes.
Okay.
So that's what we have done it here. So we are done with step 7. So as a final step, what we will do is we will ask it to apply okay. So let's get to the final step. Okay, it has reached. That's fine. So let's wait and see. Okay, so now it started working on the, see, I've said physically accurate. So basically we talked about the physics. So it was talking about the even Earth's axial tilt, which is 23.44 degrees, and then rotation direction and rotation period with the proper exact time, and clouds rotate with Earth but slightly offset, wind drift. So it's exactly following the physics, and it would be very difficult for human to apply these things. So atmosphere stays fixed, it glows uniformly. It's about the lighting. So then, so it started applying all these steps, step A, HA, 8B, and so now it is verifying the animation at the different frames.
Wow.
Okay. So all this can be controlled at what speed, and this we are just presenting it here, but we can save this as a 3D object, and later these are all pixels, because PC is unable to handle at this moment, because parallelly one side it is going through the code changes, and on this side it's presenting also. I'll just put this off. Then we'll. So this, when we save it into a proper 3D object, so we call it as GLTF or glib, GLB. So all these animations will be part of that, and this can be used in any virtual reality or augmented reality or even game engine everywhere. So this scene can be converted into VR app in few seconds, and we can plug this to the VR headset and we put it to some kid, and he will able to experience it as if he's watching this very closely. So we can make a brilliant VR educational apps, how Earth rotates on its own and how Earth rotates around. An entire ecosystem can be built, and that should be the target for Sejal to do. So I think machine is GPU got activated in the back end. So you can clearly see different continent ocean patterns of the frame 150 versus frame 1. The Earth has rotated. Now let's try. Do this animation. Okay, so by this time this gets ready. So now anyway, it's automatic. It's almost is getting to an end, our demo. So now, can you guys share your thoughts on what could the possible mechanics behind this, or what's happening in the back end of this, or how this orchestration is working together? Because these are completely two different things altogether. And that's the power of generative AI. Yeah. So the stage is yours. Hello? Okay.
Yeah, you can hear.
Yes, yeah.
Yeah, first of all, this is fantastic. That's what I can say because I have seen people working on Blender manually,
Yeah.
building layer by layer, and it takes a lot of human effort. That is one thing. Other side, we know the potential of Anthropic Claude, but I realized that today with this Blender, it can do more than what it does usually. So that is another fantastic thing
Uh,
that I got to know today.
yeah.
Usually, we are guiding the LLM to build layers, build the components in Blender, which is fantastic.
Mm.
And yeah, it makes a lot of work easier that we can say and makes reusable components. And it can be used in multiple ways, like in VR, or it can be used for motion graphics, 3D layers. But yeah, this amalgamation of two things
Yeah.
is something blown away. I blown away. My mind.
Okay. So it's Claude Code we have used, but I think even the chat GPT 5.2 or above or Gemini can also do the same, or any open source models which are available in the market. See, the best workflow for this one is if you have a good PC, at least with 64 GB RAM and 12 GB or 16 GB of GPU, and that's more than enough to host one 70 billion parameters, a good Kimi, a 70 billion or LLM, and just set up this entire ecosystem and let it work for free of cost for you. Completely free of cost. At this moment, at least we are losing some tokens because so we have paid some $20 for the Claude. So if we have our local model, and that is going to be the most effective way of handling these kind of things. So even I was thinking in that direction also to host LLM in my local PC, because I don't have 16 GB GPU, but at least 12 GB GPU I have one workstation, and set up this ecosystem. And I just want to connect an autonomous agent to it. So we will give the instructions to it, and then that will do the rest of the work. This is the overall thing. Now I got some Thursday, Friday, Saturday, Sunday. So probably while we are doing MCP sessions and all, parallelly I'll try to do that orchestration. Okay, so next, yeah, Escape. So before we go for the most complex thing to understand, yeah, what is your thoughts on this? What is your understanding fundamentally?
Anya, again, I will say this, but you will scold me, but still I will say it. Uh,
Mm.
I think I can do everything, Anya, with MCP at least.
Okay.
Anna, I
Yeah.
have a doubt, Anna.
Yeah.
Like, did you use any like protocols here, like sockets or any code?
So that's where we'll be going next. So
Okay.
that's the reason I'm stressing multiple times to you that before you want to be something, you have to be a good engineer. And so I don't want you to be slogging your asses doing same routine stuff, full stack developer, web developer, this developer and all. If you understand the entire tech stack and ecosystem, you will be able to build a brilliant things like that. So while you're working, you have to do something crazy. So now my expectation from you guys is not doing some random shit. You guys should able to build MCPs. And now we got this MCP server. We have to customize this MCP server for our purpose, and then we have to build something crazy. So if you want to do that way, you need to have a basic, at least forget about the detailed understanding. You need to have a basic understanding of engineering. That is what I'm trying to say here. What we will use, how we are using, how they are connected, because where we have left in last session at the TCP. So we have left a TCP demonstration, if you remember. So we are starting from there. Okay, yeah, let's continue.
Yeah, Anya. I
Yeah,
only by doing everything, people will get experience about everything. Like it will take some 10, 15, 20 years worth of careers previously for any software engineer who is actually curious about everything to learn about everything. But with these tools and all, I think we can compress that timeline. And I don't know what conclusions these kinds of things will bring, but I see just possibilities.
there are immense possibilities, but who uses it is what matters. Human life itself is a possibility. If you heard correctly, Rahul, that's what this guy used to say, na? Sadhguru.
Yeah.
So it's an immense possibility. So that's the reason we are able to do these things, a brilliant stuff. Now, how you use it is what matters. I'm just trying to guide you in a right direction. In spite of wasting your time for building some front-end applications, do bigger, literally bigger. That's what I'm saying. Some random idiots, let them do those things. Let them build those front ends. We don't care. Let's build something bigger. And to do something big, you need to have an engineering understanding. Then only you will do that confidently. Or else you will go crazy. You'll go mad. You will build something with the help of AI tools, agents, but you won't be confident. And if there is an issue, it's not that always agent will fix it for you. Sometimes agent also needs your help. That's how it works. So you should be capable enough to help that agent also. So that's the reason you need to have the fundamentals fixed and set, foundation laid and built. To build castles, not huts. Upu,
Yeah.
yeah.
Yes,
Okay,
I
so
am
now
listening.
what is that?
No, no, I just listening your motivations and your
Wow, it's a motivation. That's good.
just
Okay, so
lagging.
now, okay, so now let's cut let's cut to the chase and let's get into the fundamentals. Okay, anyway, what we want to show, it is done. And if you want me to show how it looks, how it can be saved, because we're using too much of stuff at one time. We are running multiple things in one PC. You see that this is called earth.glb. Okay, so whatever we have done, that can be saved in earth.glb, and fundamentally there are different types of formats to make these 3D objects and scenes available in the marketplace. This is one format, and this is widely used format. Everyone, any software which is available for the 3D or VR, XR, AR will take this format. So this is how we can save it, and it can save scene, objects, animations in a proper structured format. Clear? So this is what about. So now let's get back to the Claude. So first, let's do the reverse engineering. Okay. So how it is working and everything. So first, I will try to explain. Let's try to understand the entire ecosystem. So if you remember, we have already gone through the MCP just basics. We did not deep dive into it, but still, first I'll just give you the picture at the top level, and you need to connect all those things to your networking layer. Okay. So now if you come here and if you go to this settings in the developer, you will be able to see all my MCP servers. And out of that one, what I have here is the Blender MCP server. Okay. So now in this case, Claude desktop is my host. If you see any MCP server, the most important components of any MCP server configuration is host, client, and server. So now you can take multiple hosts. Either you can use Claude desktop as your host, or next time we will do VS Code. So you can use your VS Code as your host, or Cursor, or anti-gravity, or any other thing which has and MCP capabilities in it. Okay. So now how you connect, because host is fundamentally consists of an LLM model, or it is connected with your LLM model. That could be any LLM model. Okay. Gemini or GPT or Claude, even Copilot. So now how it should have an interface where you are able to connect your MCP server. So if you come to the settings, at least for the Claude desktop, and come to the developer, and you will find this. So here you don't need to do anything. It's very simple thing. You just need to click on edit config, and that will take you to the Claude desktop config.json file. Okay. So this is how it looks on the right side. If it is visible for you on the right side. So it is a simple JSON file. So each server, I think if you remember my previous session, I have explained about what is JSON. JSON is JavaScript object notation. So each server is your JavaScript object. And in turn, this can take a key value pairs, or it can also take arrays in it. So how many servers I have? I have Unreal MCP, and I have Blender, and I have everything Fetch, and these are all other local servers that we have built. Okay. So these are the servers. So each JSON object. So if you know Python, each dictionary, the dictionary in Python is equivalent to JSON object. It looks by and large same, with slight difference in syntax. So now I got the Blender. So what we have written here is, so we have written that UVX. So when I open this Claude desktop, it should run a command UVX space run space blender MCP. Okay. So that's the fundamental idea here. That's what happens from the host side. When you run this, the client will be ready. So anyone knows what is UVX before we go to the, oh, sorry, this is acting something, we missed it. So this is your Sejal.
Yes,
This
sir.
is your viewport, and this is your rotation following the physics laws.
Hmm.
And you'll be able to see the light, darkness, because your light is coming from this side. That could be a sunlight. And then on the other side, you'll be able to see the darkness. Can you see that?
Yes, sir.
Okay, so just let's pause this one. And just leave it like that. Okay, so now let's get back. Can someone tell what is UVX? Because it's very important. All Python purists. Okay, I think another Bhargav has joined. So just give him the, let's give him the quick brief about what had happened so far. So we have used AI, basically our Claude and MCP server to build this 3D scene in 20 minutes with zero knowledge about the 3D graphics or visual effects, including animations with pure physics applicable, with pure physics applied, all the physics laws. Even you can add gravity to it. You can create a universe, and that's what my goal. I want to create a virtual reality application where I want to create a multiple universes, and you should be able to go from one universe to other universe, just explore all that stuff. So this is my dream to build, and then enjoy it in my virtual reality headset. Because I feel I want to see those things, and it's not possible for us to see. At least we can make our own virtual reality world. How is it? How is it, Damache?
Are there not any open source models? Like,
This extent,
can we
no.
directly import it?
No.
Okay.
We will get assets. We will get some assets for these all. For planets and everything will get assets. The textures, everything will get it. But this entire scene, entire thing that I've told, that won't be available. Even see, it's very expensive one. VR, AR, XR is very, very expensive. Okay. Even if you build a basic game, they'll sell it at a highest price possible. Even for the kids, they'll make some mathematics based some VR app, and they'll sell it at highest price possible. Because it's not that simple. You need to know a lot of technologies and tech stack. Then only you'll be able to bring all things together. It's a very complex art. If you do it, it would be crazy. And there is a biggest blockage is, so you need to combine multiple things. You need to bring a 3D graphics and visual effect, and you need to bring the physics understanding, and you need to bring the mathematics understanding, and you need to bring a virtual reality VR, AR mechanics together, and plus a software knowledge. And at the end, you need to deploy it. Again, the ops knowledge. Who can do all those things together? So they were frustrated and they left it like, okay, some big companies only doing it. But we will do it. Okay, so okay, so now UVX. Let's. What is UVX? Python guys. I know some Python purists are there, Rahul and Bhargav Ram. Quickly, we have 1
The
hour to
package
complete this.
manager.
Okay, what does it do? Is it similar to? Yeah, Bhargav, speak out.
Sorry, I had a one status call in between. Like I didn't much focus on like from
Okay, that's
past 40.
fine. Okay, that's fine. Yeah, no problem. Okay, so Sejal, what is UVX?
Sir, UVX is a tool
Okay, that's great answer. It's a brilliant answer. In fact,
that creates a Python environment,
yeah.
something like that.
Rahul, can you nominate Sejal to no, Nobel Peace Prize? Okay,
Nobel
that's
Peace
fine.
Prize.
Yeah. So it's very
Okay.
important. If you see, you got the npx. I think if you use Node.js or JavaScript, you know the package called npx. So which when you say npm init, okay, npm space
Start.
-y init space init, it will create a project repository. Correct? Yes or no?
Hmm.
Similarly,
Yes.
in
Yes, sir.
Python,
Yes.
we have some frameworks such as Django, but they are creating a framework, entire framework for running web applications. But we don't have anything as such in Python before. But we got UV, which is when we say UV hyphen Y hyphen UV space hyphen Y space init, it will create entire Python project, including virtual environment setup in it. And then it will
Hmm.
able to run our server. So that is the reason when you want to run MCP servers, you have two options. Either you use a Python language or you use a JavaScript or TypeScript. So if it is Python language, it's always better to run UV because you have your MCP server. Now your MCP server should be running. MCP server should be running. So if it is a Python, you have to run Python space that file name server.py. If it is JavaScript, you will use the JavaScript commands. So now, what is the best way? If you are using normal Python code, it won't be that effective because you need to create entire environment. You have to install the requirements.txt and all that stuff. But if you give the same command to UV, because it's an entire package manager, so it will do everything for you. So that is the reason when we create MCP servers, the best practice is used to use UV or Python and npm anyway, that's normal for the JavaScript. Okay, so now here, if you see this example, Unreal MCP, my server is fundamentally this Python. This is Unreal MCP server advanced.py. That's where my source code is lying. So we will not be seeing the code, how to write a server code today. We'll do it at the right time. But for now, I just want to give you the important understanding. So this, when I say Python run this file, it will start a server in this computer at a particular port at a particular IP. So it's not internet protocol at this moment, but you'll get a local host. Okay, at certain. So now, so fundamentally, your server in Python environment in your local machine in your RAM running an application at particular port. So that's your MCP server. So your MCP server, this I'm only talking about the local MCP servers. You can have local MCP server and a remote MCP server. We are not even getting into the remote MCP server at this moment. I'm only talking about any MCP server. If it is a Python, it is a .py file. If it is JavaScript, it is .js file. Okay, so that file, if you run that file in Python environment and host it at a certain port, that will become our local MCP server. So now my Blender is also running in my local machine. Okay, so now how will you check whether it is running right or not? You will able to see the logs, because my Blender is also Python MCP server only. You will able to see these logs. It's continuously getting updated here. What's happening in now? If you see the recent one, you can see that 2026-03-17, which is now, and 11:06, the time message from the server is it has sent this information, and you see that we got the frame 300 rendered 360 degrees rotation, because I've told the last command that we have given is to add the rotation. And see, this is the communication that our MCP server is doing with Blender. So now we are still at the MCP server. We are not going into the Blender. So fundamentally, a local MCP server. So now you guys would able to understand. We got the CLAUDE code as our host. So if you take an example, a simple analogy, host, your house, let's take it as a host. Okay, into that you're going, and or let's take it as a restaurant example. It would be much easier. A restaurant is hosting a client. Okay, so someone from outside is coming there and sitting inside the restaurant. Done. So now CLAUDE code is our host. It is a restaurant, and we will have a client which will also be part of the host only. It won't be outside. Okay, so this, and now where will be the server? So server will be either in your, what is that called, like where this cooking happens. So you'll get the food from there, and he'll come and he'll go back, come and go back. So that's how it is. So now in this case, our server, where the maximum work, like how the server at the hotel takes the order and brings the food, the same way our MCP server takes the order from the host, which is in this case, it's a CLAUDE code. It could be Visual Studio Code. Okay, it takes the order from here, and it will communicate with whatever tools it is possible, and it will get the output and give it back to the host. The same way how the server takes the order and get the food from the chef and give it back to the client. That's how it works. Now we are only seeing the host side, and in the host side, the most important file is config.json. Okay, that is the reason the first thing I have taught you was JavaScript object and then JSON, because if you don't understand this, you will never able to use them well. So now I think for you, the CLAUDE, for you, the host is clear, client is clear. Of course, here in this case, we are not creating the client manually. Host will take care of the client. Okay, now let's get into the server. Where is my server? So let me get to the D drive. And here, if you see, this is my MCP servers folder, and all the servers, whatever you see here, the Blender server and the My Starter server and node modules. This is the additional and other Python weather server. You see this Python weather server. This is my Python weather server code. So all are sitting in my D drive. And so I need to have a proper environment set up here. So who will start the server? So you can start the server and keep it. But normally what it does is when you give this as a config here, so when you restart this Claude code, it will start the MCP server as well. Okay. So till now it is clear. So before we move to the next level. So next level would be a little more complex. And that will give you a better picture. Is it clear?
Yeah.
Escape?
Clear until here.
Bhargav? Bhargava? Sejal?
Clear, sir.
Upu?
Yeah. Clear.
What is clear? From the brain?
Configuration. Configuration setups are done.
No, what did you understand? Okay, so now, anyway, these theoretical concepts we will again see, but I'm just giving because I want to tell you the most important concept that you need to understand. So now at this moment, we will only be working on local MCP servers. We are not focusing on remote MCP servers because we don't want to spend any money for servers, hosting these servers in Google Cloud or Azure and all. Okay. Now, I hope till here it is clear. Now, if you see our Blender, now where is my Blender? My Blender is here. Okay. So now, how can I connect my MCP server with the Blender? So can someone go ahead and explain this one? So what are possible ways according to you? So I will try to show you the server code as well for you, for your benefit. So this is my server.py. So I'll open another. Okay. So
Before this, can you just show us the configuration file JSON for any server you have open?
it's for all servers. It is at this is our file. It's very simple file. It's
.json file.
just a JSON object which consists of
Yeah.
all servers. Like each JSON object in this is a server. So my first JSON object is Unreal MCP. That's one MCP server. Next is Blender. So what is JSON object? Anything which has been wrapped inside a curly braces is called JSON object. So it is similar to your dictionary. So the JSON JavaScript object notation, the term itself came from the JSON object. So JSON, if you want to wrap multiple items or elements or entity into a single object in Java, there are two types fundamentally. One is array and second one is JavaScript object. It's called JS object. The name itself is object. Okay. So array is fundamentally similar to your list in Python. And JavaScript object is fundamentally similar to your dictionary in Python. So it will be written within curly braces, and under that it will have a key value parameters, and it can again take the sub objects, etc. Okay, so let's get back. Is this clear?
Yes, perfect.
Okay, so now let me come here to the so this is my server, MCP server code that I have written for the Blender. This is not the right time to go through this, what we have written, how we have written and all. This is not at all a right time. The focus of this session is different. So, but just for your benefit, I'm showing it. It's very simple, a Python file. Any Python file. It is not too complex. Anyway, we will come back to this at the end of this session. But for your benefit, if you would have written a Python file, you would know this. And this is how the closing. Clear? And so now my question is, your MCP server is there. The code is there. It is fine. In your MCP server, you have written, these are all things to be done. But you have a Blender, which is a completely different application altogether, which is fundamentally written based on C language. So what all the possible ways to communicate with this particular thing? Anyone, just speak out. It's kind of a brainstorming only. You don't need to worry. There is nothing right or wrong.
How do you communicate with Blender?
Yes, obviously. Without communicating Blender, how will you create these things? This will
One
lead
thing
to
is you
trace.
can
Yes.
manually, it is a vector space, to my understanding at least.
So
So we
vector
will be
space.
creating, so whatever we
Okay.
create, right? So it will be taking up some dimensions in vector space. Some units will be given, and
Okay.
it takes a shape.
Okay.
So
Next.
it is all done manually now.
Okay.
That's one way
So
of
how do you communicate
interaction.
with it? What is the possible way?
gRPC, or we can use
So what is gRPC?
like remote processor call, global remote processor call.
So yeah, that's RPC, but how do you connect with this one? So with that, okay, that's one option.
So like
And
that.
so that, but here in this case, both the applications are in the same machine. So
Or
fundamentally, it
else,
is using RPC concept only. So
yes.
that remains same. See,
So,
your fundamental concept remains same, which is JSON as a file interchange format, data format, and RPC is to communicate with the another machine or another application. That remains same. But what is the method that you will use? This is a protocol. RPC is one type of approach, a method, way that you are using. But how do you communicate with this one? SK.
Blender needs to write a server that they will expose, and then later on our application will try to ping that server, particular port number or IP number or whatever it is. We will ping with
Okay.
some information. It will take that information and do the process.
So what is that server? How is that possible? Blender will write a server. What kind of server?
Um, the HTTP server, some communication worthy server, HTTP server only, some kind of.
Okay. But normally, how do you communicate with another application? Can you just go
like we
from
can
basics?
use REST, na sir, REST APIs or WebSockets. We can
Yes,
use.
Amalapuram came into right direction at least. Yeah. So one approach is APIs. Normally, all MCP servers are fundamentally based out of REST APIs. Because, for example, if you want to interact with your GitHub and do that, like you just give one command and it will do all or everything, all tasks and activities in your GitHub. So everything in your GitHub, so all through APIs, and like even your databases, SQL queries, if you want to do some operations, fundamentally with APIs. So is that possible here, REST API?
I think WebSocket is possible.
You think WebSocket is possible? What is WebSocket?
Like it's used for bidirection communication, as yesterday
but
you have
what?
explained. Like the communication between server and the like host and what do you call that, a Blender. So we can use sockets.
Yeah, park this for now. We'll get back to you. The WebSocket. Whether, okay, next. So is it like, is it, what is the other way? So is API approach possible here?
Yeah.
How?
Same way, if there is some
Quest,
endpoint that is receiving the API request, then Blender needs to implement that endpoint.
okay. So what is API? Again, you have to get back to that question then. So what is API fundamentally? API is
Communication, it's used
it carries
these
yeah, JSON
clients.
request and JSON response in the
Yeah.
simplest way through
Yeah.
HTTPS plus TCP with
Yeah.
WebSocket.
Yes, sir. Yes, sir.
Okay, the simplest definition, the shortest definition. Now, so it's given JSON. Let's imagine, let's take it. It is given JSON. What the hell it will do with the JSON? Because it's a as Rahul mentioned, it is a 3D space and it's fundamentally a vector space. Whatever you see there, you will it's eventually converted into vectors. Okay. So now, how would you convert this 3D? How would you convert your JSON request into a 3D object? For different for other applications, it's a different story. For the web application, it's not a web application. First thing, it is a local application which is running on my PC. So how would you do that? Think. You guys are in the right direction.
We have to write some sort of compiler.
Okay. Okay. Next, go ahead. Continue.
MCP.json.
That's done. That portion is done. JSON is done. What's next? Data interchange
can-
format is not an issue. We'll use JSON
You
only.
can give dimensions now, sir. Like sending JSONs, you can give dimensions now. Like how
You will
much
give
size?
dimensions through JSON, let's imagine, but how would, see, you have an engine. Okay, Blender is an engine. So I hope you guys understand this. This is, see, what I'm speaking is core engineering terminology. When we say engine, like for bike, you call it as a bike engine. Okay, so there's some per activity. Same in computer engineering, we'll call game engines, we'll call these software engines or graphic engines and all, which is fundamentally a 3D, sorry, not 3D, a piece of code which is wrapped in an environment with a front end, a UI UX together. So that's normally called engine. And on top of that, it has a lot of plugins and a lot of add-ons. And also there is an environment which is already running in it. So these are all called engines. If it is C language based, it's a C language environment is running. You'll be able to write code. If it is JavaScript based, JavaScript environment will be running. But fundamentally, a lot of all these applications would be C hash, C sharp based things only. Okay, I've given enough explanation. Now you guys can figure out automatically. Yes, go ahead. Don't stop, man. This is how you will learn. Hello? Okay. Machi, am I audible?
Yeah, you are audible.
Yes.
Yeah, continue. But there is no, you guys are close. You don't need to be quiet. It's good. You guys are able to understand some extent.
Any library in Python or like I don't know, I'm just random throwing stones.
Escape, it's better you speak out. Yeah, you're in the right direction. But Eskid initially spoke something and then he screwed himself. That means he randomly throwing some stones also. He doesn't have any. He doesn't have any clarity. He's just throwing things. Initially, he
No,
said
no.
something.
I
Then
have to
speak out
give
now.
proper answer or else not give any answer. That's why I'm restricting myself.
Machi, parda Eskid. Okay, so I think Eskid and our Amlapuram, by and large, there were some mistakes, but they have captured the essence. Okay.
Yeah.
So if you see this, it is not only this. This is applicable specific to this kind of engines, whether it's a Photoshop engine or Unreal Engine or Blender or Unity. It is applicable for these kind of things only, majorly. If it is a web application type, then we will purely go with merit of API. So there we will use APIs. But when it comes to these kind of things, APIs are not possible because there are no APIs for these things. Okay. So you cannot give any API to MCP server and MCP server call those APIs to execute something. And that's not possible. So the only option we have is, as I've told you before, it's called engine. It's not called a simple application. It has a Python environment in it. You will be able to see that scripting. You see that? I've written X, I've written Y, and X plus Y is equals to 3. So there is a Python environment in it. But it's fundamentally C-based engine, but under the hood it's C, but it takes all Python because Python is also good at math. So, and manipulations. So number manipulations, they have used Python. So I hope you guys are understood this one. So now what happens is, what we need to do is, now Eskid initially has highlighted that. So we have our MCP server, which is running at one particular IP and port. Okay, we can call it as a socket. You should not call WebSocket at this moment. Okay, now, so our MCP server is ready to give or transfer instructions in JSON format and take the response from this in like what it has done, all the information in JSON format. That's the maximum capability it has. Everything should be done by this, like it will receive something and the actual heavy lifting will be done by your Blender. But there should be someone to do this because you have the environment, but there should be someone to do this in this environment. Either you do it manually or you spin a server here to do it on behalf of you. So it is not a normal web server. Okay, because it's not possible with a normal web server. We need to take a completely a different approach. So now what I have done is, so if you come to not only this engine, it is Unreal Engine or Unity or any other engines, any gaming engines, you will have edit option. Under that, you will have a preferences. Okay, in preferences, you will able to click on add-ons, and this add-ons will take an additional. This one will take Python based server. So I have added a Blender MCP add-on to this. Okay, so let me click here and you'll able to see that. So where is my source code? My source code is C drive users Charan app.roaming and then Blender Foundation. And this is where my file is sitting in my local, and I have connected this with this one. Okay. So now what is this? This is an add-on file. Let me open this, how it looks to show you. Let me open it. Now we'll be getting into the most important.
But this add-on will also use TCP/IP protocol, right?
Wait. So now you got this. This is your basic a file which we have written, and it consists of utilities and functions to do some activities, and you'll able to see the register. So at this moment, we will not go in detail about this file source code. We will do that as well. Okay, but this is the file. Now this is not a normal web server. Okay, because if you see this, it doesn't have any way or method to run it in a normal way. You see that? If it is a normal web server, it will be run in a different way, but it is in a different format. It's a register. And if you see all those things, it is doing something else. It is not a normal web server. Okay. So now the most important thing to understand is here, we just need to add this and it will be integrated with this one. So what is this server called? It is a TCP socket server. It is not a web server. So we are actually fundamentally getting into the core engineering concepts. A real application of these engineering concepts you would have never done in your entire engineering career. You would have heard, but you would have not used it. Here, I wanted to demonstrate with some simulated files, but we are actually doing it with the TCP socket. Okay, so now we have installed this, and what I have to do is, let me close this. So here, once you come back to your layout, okay, here you will be able to see whatever the add-ons that we are adding. So at least this particular one, they will give those tools and all these details information here. So we will able to start our server from here. So now what we have done is, it is very simple. One side at here, we have installed a TCP socket server so that it can take instructions. Literally, it can take a source code from your MCP server in JSON format. And then this will take that code, and you have the Python environment, and it will execute that code and it will create your 3D objects. And that's what the flow. Now, the biggest question is how this MCP server and this socket server is going to communicate to each other. So that's what the demonstration that we are going to do here. So if you remember last time, we have discussed about the sockets. Okay. So we have put the two sockets here. We just want to do the demonstration, right? Last time, if you remember. So I got the client and I got the server. Let me close this config. And here, if you see this, one is my client, which normally, if you see from the web application perspective, this client would be sitting, that particular code about the socket connections will be written inside your browser. It's a Chromium extension normally. Okay. And your actual server is sitting somewhere inside the AWS or Azure or Google Cloud. Within that, the main file, in that file, they will be writing the respective things. Okay. Now, through internet protocol and through TCP and all that, that connection happens. So now to understand this TCP, I'll just demonstrate it here first. Then we will go to the, as you need to have client and you need to have a server, then we will establish a socket. So now first we will look into the socket. How do you create a TCP socket? And is port and socket are same? Before we understand this, can anyone tell me, is port and socket are same? Quickly, you can give binary answer.
No.
That's good. Is WebSocket and TCP socket are same? Or socket, WebSocket, TCP socket? Binary answers also fine.
Yes.
Thank you. Greatly appreciated. See you soon. So let's get back to this one. Now, so as JavaScript is your fundamentally web language, so it has all the modules which are natively available in JavaScript. So what we use to create a TCP module is your net. Okay. So here you see that this is where we are creating the net.create server and then socket. This is basically this kind of code we may not write in our web application because this happens internally. So what we write is basically listen at this particular port. Okay, but I'm just trying to show you, because if you want to understand things one step ahead, you need to understand how do we implement as a developer and what exactly happens at the computer level. Also, we will be seeing these sockets, how a developer uses it, and how this interaction happens at the computer hardware level. Both we will touch. Okay, so now this is how you create your server and you create your socket. Okay, and the communication. Now what we are saying here, if you see that server listen at this particular port and at this particular IP. Okay, forget about this. What is this port? What is this socket? Whether they are all same or not? How are they real or they actually exist? Just my question, another question. Port and sockets, are they real entities? Are software abstraction or your computer abstraction? Binary. Binary answer is okay. No
Computer
cross questions.
abstraction.
Thank you. So now this is my server. So we have created a socket. Now this is a purely socket level connection, purely socket level connection, which is happening at my PC on my hardware or in my RAM. Okay. So now this particular socket, a TCP socket, is server.listen at this particular port plus IP. Now on other side, let's come to the client side. If you want to create a client, so now we have to create a client in this format with the host and then port, because they have to communicate at the same place, right? So that's the reason my client will ping server at that particular host and port. Now let's first run the server. Always your server should be up and running first. Okay, so let me say node and then server.js. So my server is up and running. What it's saying? TCP server. This is not a normal web server. For God's sake, you should differentiate that. Okay, web server is absolutely different. That's the reason I've asked, is TCP socket, web socket, and socket or same or not? Okay, so now this is a TCP server listening on port 3000. Now it is waiting for client ping. So now let me run the client, which is this. So now client has pinged at this particular socket, okay, which is 127.0.01 3000 on my RAM, on my random access memory. These are all random access memory. Whatever action is happening, it's happening at the RAM level. So now let me say hi, and this will be converted into bytes. So that's how the data transfer happens at the low level. So, okay, it will be converted and it will show in a high level, but under the hood, that's how the data transfer happens. And it happens from one side, your TCP, your client to server. Now, let me say hello. and you'll able to see this here. So I've said here, and then you got what client is saying. And so the fundamental thing to learn from here is we have run the server client and we have said something, and that information got transferred through TCP sockets. Here there is no HTTP, no URL, no request, because HTTP is fundamentally hypertext transport protocol through web. So here, so we have no HTTP, no URL, no internetwork. Okay, no internet, which is fundamentally no internet work. Okay, that means we are not connecting with the subnets and other networks which are available across the globe. So it's a purely a TCP sockets. So we have created a raw bytes flowing through the pipe. And so now this is what the fundamental TCP socket is, the main block for us to build this entire ecosystem. See, the guys who doesn't care about TCP socket and they don't give damn will never able to build this because they don't know. And with bloody TCP socket, you are able to do this. Of course, you have tools, but if that is not there, you will unable to do this. So now let's actually try to understand this concept one step ahead. So now you understood that you got a CLAUDE, okay, and here our MCP server at, and it's waiting for a particular location that we have seen that you are localhost and then 9728. And here at my Blender, I have my MCP, my TCP server, TCP socket server, which is listening to that particular port and that particular TCP socket. So it's fundamentally a TCP socket transfer, nothing else, absolutely nothing else. Now, this you understood how to add a TCP socket. So now if you see this add-on file, if you see this add-on file, at least at the top level, just to get understanding, what we have imported is TCP socket, the most important thing. Then we have imported the threading because we want to do the multi-threading, and it's Python. So Python doesn't have a direct async capabilities. So we are pulling up multiple things to do these things. And you got the Blender Python module, which is a Blender Python code, which is Blender API. It's kind of its own library. Okay, so now the first things that we are doing here, you see that localhost and 9876. So this is where it will be running and listening. So our another server will also be connected to this particular thing. Now here, this code is very important for us. This particular code, create a socket. Guys, are you there? I hope. Yeah.
Yes, sir.
Escape.
So can we say if WebSocket is just a type of TCP socket?
Let's see. Any other question? Rahul? Upu? Are you there? Upu or cooking something?
Yeah. Yeah. I'm here.
Mm-hmm.
Okay. So now, if you see this, this is where we're starting to create the socket. Okay, self.socket, if you know Python, it is basically we are creating class level objects, and later they will able to create and refer to the objects that you create. So these are called class level objects. I think in JavaScript also they have a different keyword, and here we use self. Now we are creating a socket, and this will have a continuous stream. And we have attached, we are binding this socket. Clearly observe, I am teaching you the fundamental blocks of computer science engineering. Okay, so now we are binding this particular socket object with the host and the port, and hence it become a TCP socket. Okay, we will see how it interacts with your hardware. That we will see, not to worry. I'll show you that as well. Now, of course, when you create a socket, and then the next important thing are threads. So you need to run these threads. So that's what we have done it here. Because it's a Python, we use these threads. Now, after that, we are just clearly printing if it is ready. Blender MCP server started on here. And if it is not, it failed to start. So, and here below that, you have more utility functions for all the stuff, threading and everything. So that I don't want to go now. So this is what we have done here. And similarly, let's go to the server.py. So here again, we are importing the socket. Okay. So now the first thing is, and here default host and default port, localhost 9876. They are also localhost 9876. They will be listening to each other because it's a TCP socket connection. Then you got the class that we have created. This is how we create. And this, if you remember Rahul, it is, there are different types of classes, public, private classes, and abstract classes. And when you say at the rate of data class something, it's a type of class that we are creating. And this is our object that we have, the class level variable that we are defined. And here we are creating that particular socket the same way. What we have done there, by and large, we are doing it here. So we are fundamentally creating two TCP socket servers at who are operating at by and large at the same host and port so that they can be connected. So then after that, we are, this is for disconnect. This method is for disconnect. And what you see here is from the server, because my server.mcp server is going to do a connect. So that is the reason under this class, we have created a connect method. So this method will initiate a connection. So this will initiate a connection and that will do a handshake. And once it is set, and rest of the operations happen, and all through socket. Okay, I hope for you, how do you write a socket from the developer perspective, at least is clear from Python language, like through Python. So JavaScript is much easier than this because I've shown the JavaScript in some other demo. Is it clear? Shall we go ahead next to next step before we wrap up today's session? I think if everyone gets tired, it should be me, not you. You should not shy away, or you should not shy away for speaking out.
It is clear, but I'm still not able to grasp
Confused.
why we are learning TCP sockets and all when we are talking about MCP. I mean, we are doing a TCP socket call
You did
without
not
doing a
understand?
WebSocket call. So, okay, but is it necessary to learn this? Is what I'm thinking.
See, whatever we have created here, like it was possible only because of TCP socket connections. If that was not there, it's impossible.
Why did we learn this OSI layer and all refresher?
So that's for the web. So that's for the remote MCP servers and other MCP servers. For this is a one type of approach where you need to know
Okay.
these things. So now the next, and even if even if not for this particular purpose, still you need to understand the TCP layer, right? And how it
Yes.
interacts with your PC. That's very important because see, now as you go ahead, see, you guys are unable to understand one thing. You're only seeing things from top level. Okay, you guys are not deep diving into the things. When you want to build even an agentic ecosystem, how these guys, okay, creating a basic agent, writing through prompts, that's all one thing. Or maximum, you guys would like to use NA10 and then connect some things at the top level. And who will do that? Any Tom, Dick, Harry can do that. That you should not do. You should do one step ahead. So when you build a lot of agents, how these agents can communicate together. So that's where the actual fun comes. And we need to work at that level. If you want to do this, because that's the future. Now, what is the future? Coming future is autonomous agents who are able to communicate with whatever is available in the market, provided that you have enough permissions. That's
Machi,
again, it's,
yeah. So this is for connecting with Blender, right? And
yes,
we have other scenarios as well. So that
yes,
requires API, HTTP methods. Uh,
yes.
yeah. So
If it is
that
other scenarios, anyway, we will see. So this, it within your environment, if you have an application like this, you have to use a TCP. If you have web APIs, you will use web APIs through MCP. Okay, so then there it's a purely HTTP protocol plus WebSocket.
So I have
So
one
these are,
doubt.
yeah,
This what we are talking in this whole class is that it's directly the transport layer protocol. We are not at the top level, but we are deep inside the OSI layer now. But uh, again, if we wait for 1 or 2 months, someone might build a library to make it all, top level. You will just import a library, just like LangChain. Instead of building custom-made everything, we can just use LangChain, right? See, in similar way, instead of writing all this TCP ports, sockets, connections for every single thing, we can just import a library and do it on top level, right?
no, you're still not understanding the thing. Even now, you are not writing this. Somebody has already written this. Okay. But what I'm saying is you need to understand this so that tomorrow you are not on consuming side, you are on producing side. For the God's sake.
Okay.
At least one of you guys, if you get into the producing side, I will be happy. And it's not too complex to do that as well. So now, anyway, we'll get into that other protocols also in the next step. But now, so let's try to go through this. How this, anyway, these concepts are required to be, you need to understand these concepts well so that you will able to clearly differentiate things. Let me open this anti-gravity. Because anyway, the TCP is a complex thing to understand at any time. Now you have seen, and of course, if you want to create something new or do something crazy, so at that time only you will able to do these things. So the fundamental difference why OpenClaw is created by an American guy. Why not Indian guy? At least sitting in India. Because we are on consumption, consuming side, whether consuming side to develop something, but not for new thing, not to innovate something. Because we are not worried about those things because our colleges never taught you. You were never wired you. They never wired you in that direction. They told you there is no JS library, go and pick it and build something. They told you there is a Python library called pandas, run something and build something. They never told you how pandas work. The moment they tell you this, you will think, okay, let me make some pandas. So let's get back to this. So now, because if you understand TCP, other topics are fundamentally easy because in that TCP IP layer, you got 4 layers. One is link layer, physical layer, which is anyway, you know, these are physical objects, and Ethernet cables and Wi-Fi stuff, and then those particular pins and everything. And on next layer, you have the other layers. You have TCP and HTTP, and in between you have. So out of these 4 layers, other 3 layers are little easy and it's easy to grab. So now, if you understand this TCP particularly, because it's little complex, because it interacts with your hardware as well in your PC or in the server. So it's little complex to understand. If you understand this, rest other things would be damn easy, and you will get a clear picture of how entire thing works. So now let's take the same example, like whatever your Blender and your Claude desktop. Okay. So let's take this example only. Now, let's imagine you got a physical hardware, which is an Ethernet cable. Through that, your data is connected. This is just take this out. I was just giving this example just to connect it to your overall OSI and IP layer. But normally through your Ethernet cable, so your data, whatever is coming, that is coming through bits. Okay, and then that will reach to your, this is, it is anyway, it's visible to your eyes, this, the speed and all that stuff, this is visible to eyes. And this is where the actual game starts. Let's come to the hardware stuff. This is where, so there is network interface card. Okay, so network interface card, it's a physical one. It's a chip normally soldered directly into your motherboard. And in some PCs, it is, of course, it would be a separate one. And it's also it's also dependent on your RAM and what extent of buffer they're attaching to it and all. So this will have a physical connector with your Ethernet cable plugs in. Okay, so you plug some Ethernet cable, it will be connected to your NIC on your motherboard. Okay, what it does and all that stuff you will be able to see. Analog to digital, it will convert that, and it will go into the binary zeros and ones. And at the top level, this again connected with your voltage and amperage and all that stuff that we are not getting into it. Okay, so now I'm closing this one. So now you're getting some data through the internetwork, through Ethernet cable, and it went into your NIC, network interface card, and there it's basically convert that analog voltage to your digital bytes and assembles them into Ethernet frames, and it's ready. Then there is a DMA controller within this CPU. This DMA lets NIC directly writes to your RAM, your random access memory, without interrupting CPU. So whatever the computing process is going on, that will continue parallelly. It will do this. So that's your DMA controller. So this is basically data, how data is coming from your internetwork to your PC and to your RAM. So we have reached to the RAM. So this is where the crazy thing is there. This thing you need to understand. I will explain you multiple times. If not, it's clear. So now this is your RAM. Let's imagine this is a RAM space. And this particular DMA controller is connected to your RAM. And the information, whatever it has received, has been converted into digital and has been posted into the RAM. Okay, the random access memory. Okay, so that depends upon the bit bytes. Okay, so now at a particular memory address, hexadecimal memory address, that information has been written into your RAM. Okay, so now in your physical RAM, you will have this particular information has been written into particular addresses, the abstraction layer. So the data, so how that data format, raw internet protocol packets written by, so this anyway we have discussed before. Now, so we have reached to a stage where your data entered into the RAM. Now the craziest thing comes. I hope you guys heard about the kernel. At least if not you, Rahul would have heard multiple times because I've taken a lot of sessions on kernels, Linux and GNU, how GNU came, what, so GNU, like Linux is not Unix, and all that stuff we have discussed multiple times. Now, so the Linux is the most important component of any, sorry, not Linux, kernel is the most important component of any OS. Now, so your random access memory has data under which you got the kernel. Within the kernel space, this is where the actual socket stuff, TCP stuff, WebSocket stuff, everything comes into the picture. The first question that we have discussed, whether port is a real entity or not. It is not. Okay. Port is not a real entity. As part of the OS, as a part of the kernel, because kernel is fundamentally a software system which is designed. It's kind of a utility which is written with the low language. Okay, so now, so while they write a kernel, while they design a kernel, okay, so they will create a port lookup table. So they will actually have an array stored in RAM, so which is connected with your RAM. So it is not a physical port. So now it will have information, and it is by and large decided this particular port is for this purpose. So 22 is for SSH, and then 443 is for the Chrome browser, it's for the web, and that will be eventually converted into WebSocket, and 9876 is for any other web application, any other local applications. Example, here I've written Blender. So now the first thing you need to understand is what is port, because you say port multiple times, probably 1,000 times. My application is running at this particular port. You should know what is that port. So port is absolutely connected with your kernel space coding. Okay, so it is a table, and which this table has been stored in your RAM space. I hope this is clear. Now, so now this is the port. Now the most important thing is TCP engine. So this is again also part of your OS. These are all a software abstraction. These are not real entities. These are all part of your kernel design. So whichever does this well, their OS is the most efficient. So when it comes to when it compared to the Windows, your Linux is efficient. So now Eskid may design a new kernel altogether, and he can name Eskid. Directly you can name it as Eskid, the OS name itself. So then, fortunately, we have only one OS that they have designed from India. I don't know if it is working well or not. So then we got the TCP engine. So where this is also again a large piece of C code compiled in the OS kernel. It is not a hardware, it's not a real entity, and there is no TCP chip or nothing. It is again an abstraction which fundamentally consists of a net, like whenever it runs like it runs on the CPU, whenever the kernel processes a network packet, the data packet in Linux, I'm talking from the Linux perspective. So it will run this particular thing in your RAM. So basically they have arrays. Okay, they have a table of arrays. So that will, so what it does when this particular data packet arrives, it will parse the IP and it will take the TCP header and it will bring all things together and it will make another data structure in a proper format. So now a TCP engine is a piece of code which is written. It will take, example, you got a data packet from this particular URL, from this particular port, and this is the data. It will take all the information and it will convert that into a nice format and where it should reach in this particular port, and it will map all those things in a proper structured format. This is called a socket. Okay. So the socket is fundamentally a mix of the data that you receive through URL and then the port when you combine together. So the socket object will be created. So this socket object will consist of URL with the port and from where it is receiving, because it has to connect with that remote URL and remote port also, and state established and then information that has received. Again, these are all abstraction. This happens in RAM. And once that is done, so proper establishment will be done and it will receive data. Then after that, this information will be through kernel. It will follow the same process and it will share back to your Blender. Of course, here it is happening through TCP socket. Now, finally, you will be able to see that in this case, in our Blender, so we will get the Python code and Python code will be further converted into your C++ and then that will create a nice 3D objects. Okay, so now the important point for you to understand here is TCP socket is different and WebSocket is different. And so what you create, if TCP socket is this level, and if it is only connecting within your local machine and to write a TCP socket, both sides, it will be a TCP socket. And if you want to write a WebSocket, you will write with a different library. But the concept is by and large similar. Okay, these are all not real things. These are all software abstractions in your RAM through your OS kernel. Is this concept clear?
Yes.
Yeah.
Okay. Yeah. Sure. So now you will able to at least understand what when someone says port, when someone says socket, when someone says IP. So what is IP?
Internet
Socket
protocol.
address.
Internet.
Protocol.
Why it is called internet protocol? In Blender and Claude, do we have IP?
Yes.
Are you sure?
Yes, sir.
Rahul? In
There
between.
is no internet communication. No only TCP.
Perfect. Thanks, man. It is inter-network protocol.
Running on local.
Yeah, it is not. IP is internet protocol is shortcut, but it's not that. It is inter-network protocol.
Okay.
It is a protocol, which means set of rules to communicate between network to network. One subnet to another subnet. One country network to another country network. That's called internet protocol. It's not internet protocol. That's a shortcut. Okay. So now, as soon as your IP comes into the picture, your WebSocket will also come into the picture. Then it will open the both ways. So now, anyway, next in coming sessions, before we start writing our own MCP servers, let's have a final walkthrough of HTTP and TCP and IP and WebSocket, and we'll wrap it up. But at least you got some clarity right now.
Without IP address, how will you find the service or something? How will you find another person? Some address should be there, right?
Obviously, it's there.
So
You have given the
what is
local
the
host.
address for our TCP,
Local
TCP
host.
sockets.
Local host.
Okay.
Local host. It's in your local machine. You have given
So
local
how
host.
will you write remote TCP?
Remote is, see, that's what fundamentally when you want to connect these two, normally remote TCPs will go for the web sockets.
Okay.
So you want to connect with your local machine. Within your local machine, you want to connect with this particular application. So we have done, we don't need to, when you build a MCP, remote MCP, you need to have a WebSocket. You don't write TCP socket, a WebSocket. It is
Got it.
HTTPS protocol. So anyway, we will just orchestrate all things together and we'll have a clear picture of overall network layer from web browser till web server, where HTTP protocol comes, where TCP comes, where IP comes. I think by and large, you guys would have gotten understanding, and where this socket itself comes. I think at least deep level at the hardware level, you guys are very clear. Only that transfer from one layer to other layer, you might have small confusion, but that can also be cleared as we go ahead. Is it done? Clear?
Yeah.
Amlapura, any queries?
No, it's clear.
Bachi,
Clear, sir.
Rahul? Is not there?
Clear.
Okay. Perfect then. So we will drop off for today. And so you will find the source code there. And I hope Sejal will upload this video also. In so and the next thing is,
Appreciate it.
and the next thing,
Super
yeah,
class.
for Sejal. And the next thing is, I'll push this source code to the GitHub as well. These additional files to the GitHub, and you go through it. So now for the next session, as you are very much clear with the fundamentals of all these things, the next step, what we'll do is we'll just we'll just have a quick walkthrough of each layer just one more time, covering all those things once, just one quick walkthrough. Then we will write our first local MCP servers. We will write together. Okay. We will write our MCP server and we will execute those MCP servers as well. A local MCP servers. I'm not talking about the remote.
Okay.
Clear?
Perfect.
Okay then. So any queries? If not, okay.
No queries from my side.
See you then. Yeah. Bye bye.
Thank you. Thank you so much. Congrats.
Zabardast class and yeah, super.
Much appreciated. Have a
Okay.
good day.
Thank you. See you. Bye bye.
Thank you. Bye, sir.